So let's go ahead and jump into our last lesson for Chapter 7. This is our last regular lesson of the entire semester. We are more than halfway done with AP Statistics now. There's 12 chapters and we're on Chapter 7. All right. Over 1,000 students at East Kentwood High School, EK, have taken the AP Statistics exam. The distribution of scores is skewed left with a mean of 4.09 and a standard deviation of 0.83. At rival high school RHS, the scores are approximately normal with a mean of 3.07 and a standard deviation of 1.12. We randomly select 40 students from East Kentwood who have taken the AP Statistics exam and 20 students from RHS who have taken the AP Statistics exam. Use the information given to describe the sampling distributions of the average AP score for two samples. Let's do the East Kentwood together, and then I'll have you guys do RHS on your own, and then we'll kind of check in. So when I'm talking about the shape for the sampling distribution at East Kentwood, what pieces of information would we need to look at? How will I determine the shape, not of the population, but the shape of the sampling distribution when we choose these 40 students? You look like you haven't thought. No? Okay. Anybody have any ideas? What would the shape of the sampling distribution be? Approximately normal. Why? Because of the central limit theorem. And central limit theorem says what? Yes. If the sample size is greater than or equal to 30, then the sampling distribution will have an approximately normal shape. All right. So we are approximately normal. Sample size is large enough. We're using the central limit theorem. What is the mean for East Kentwood's sampling distribution? What is the mean for East Kentwood's sampling distribution? 4.09, yes. We have that right up here. Mean of 4.09 for East Kentwood. And the sampling distribution mean will be exactly the same as the population mean. What do I have to do before I find the standard deviation? 10% condition. Do you think for East Kentwood we get our 10% condition? Yes. How big's our sample? Sample is 40. Population is over 1,000. What's 10% of 1,000? 100. So as long as we don't sample more than 100, we know we're definitely good on our 10% condition. So we get a check mark here. Go ahead and calculate the standard deviation for me then. For the sampling distribution for East Kentwood. How do we calculate the standard deviation here? Yes, standard deviation for the population, which is going to be how much? 0.83, standard deviation for the population, divided by the square root of 40, which comes out to be about what? Yep, right about 0.131. All right, so before I set you guys loose on RHS, we're going to recap. When we're working with just one sample, it's approximately normal. If the population distribution is approximately normal, or if I can use the central limit theorem, 30 or bigger in my sample. Either one of those will give me an approximately normal sampling distribution. The mean for the sampling distribution will be the same as the mean for the population. The standard deviation for the sampling distribution is the standard deviation of the population divided by the square root of n. And so then my variance, standard deviation of the sampling distribution squared, would be the variance of the population, standard deviation squared, divided by just n. I'm going to give you guys about, let's take 2-3 minutes. So you do RHS. Now that we've done East Kentwood together, I want you to do RHS on your own. What is the shape for the sampling distribution for RHS? Approximately normal. Why? Because the population is approximately normal. That tells us, or it tells us that right here. Population distribution is approximately normal. Either one of those criteria will get me an approximately normal sampling distribution. And it's absolutely imperative that we know for sure that we have an approximately normal sampling distribution, because without that, we can't actually calculate these probabilities. We can't use normal CDF if it's not a normal distribution. So we have to have one of these two criteria met. What is the mean for RHS? 3.07, right here. And I know we have to check our 10% condition for standard deviation. We're going to have to make an assumption, aren't we? Because do we know how many RHS students took the AP Statistics exam? No, but it would need to be at least how many? It needs to be at least 200 because our sample is 20. So when I go to check my 10% condition, I write it down like this. 20 is less than or equal to 10% of all RHS students who took the AP exam. We're not comparing this to all the students, period. We're just looking at the ones who took the AP statistics exam. Without more information, I have to make this assumption so that I can find the standard deviation. If we find out later that our assumption is invalid, we can go back and kind of change that, but we wouldn't be able to use the formula for our standard deviation. But we have to at least show that we checked this criteria. What is the standard deviation for RHS? Yep, right about 0.25. It's like 0.250 something, 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 so I just rounded it to 0.25. Beautiful. So we have two separate populations here whose population distributions are different. One is skewed to the left and the other one is approximately normal, but the sampling distributions are both approximately normal. As we're trying to figure out what is the average score at East Kentwood, what is the average score at RHS, those sampling distributions are approximately normally distributed. If I wanted to figure out now the difference in mean AP scores, I want to do East Kentwood minus RHS. What do you think the shape would be? Approximately normal, yes. Why? Because both of the sampling distributions for the two groups that we're looking at are approximately normal. If both of the sampling distributions are approximately normal, then when I subtract them or add them, the new sampling distribution would also be approximately normal. But I have to go in and check both populations separately, check their sampling distributions. How would we find the mean for the difference in scores? Subtract, absolutely. What are we going to be subtracting? 4.09 minus 3.07. What do you get when you do that subtraction? 1.02, yes. So when I'm looking at a situation where I've got two different samples, and I want to know what happens when I put them together, either by adding or subtracting, the shape will be approximately normal if both of the sampling distributions for each of these individual samples is approximately normal. The mean of the difference, I'm going to subtract the means to find the mean of the difference. Standard deviation. How do we calculate a standard deviation when we subtract two random variables? What'd you say? We're going to square both of them and then do what with them? Square root. Can't square root yet. Got to do something with both of them before I square root. That's what I want to say, but do we ever subtract standard deviations? We're going to add the variances. Whenever we're working with random variables, whether we're adding random variables or subtracting random variables, we can't add and subtract the standard deviation. We can only ever add the variances. So how do I find the variance? How do you find the variance? Square your standard deviation. So what was the standard deviation for East Kentwood again? 1.31, so, or sorry, not 1.31, but 0.131. So we're going to do 0.131 squared plus what? Plus 0.25 squared. And then we're going to take the square root of that whole thing, because if I just add the squares together, I'm going to find the variance of this new sampling distribution, and I want the standard deviation of the new sampling distribution. We get about what? Yep, right about 0.282. So when we're talking standard deviation for a difference in sample means, this right here is the variance for the first sample. This is the variance for the second sample, so we add those two variances together, and then we square root. And don't forget, you have to check the 10% condition for both populations, or else you can't use the formula. So, with this in mind, let's see if we can go down and answer question number 3. Calculate the probability that a random sample of 40 East Kentwood students has a higher mean or average AP score than the random sample of 20 RHS students. So I want to think through that for just a second, because if it says calculate the probability, what are we going to be doing? Normal CDF. And why do we know we can get away with normal again? Yes, both of our samples had approximately normal sampling distributions. So when I put them together, I will have an approximately normal sampling distribution. What are the things that I need to know if I'm going to do a normal CDF? What'd you say? We need to know the lower boundary, the upper boundary, mean and standard deviation. Have we figured out any of those yet for this situation? Yes, which things have we found out? Mean and standard deviation, we just calculated those on the last problem. Looking at number 2. Do we have lower boundaries and upper boundaries? They give us enough information that we can figure it out, but they didn't give us numbers here, did they? What is this 20 and 40? Those are number of students. Are those boundaries? No. And when we're talking boundary lines here, remember, we're talking the mean AP scores, the average AP scores. That's what my mean is telling me about. That's what my standard deviation is telling me about. I want to know the probability that the 40 EK students have a higher mean AP score than a random sample of the 20 RHS students. So something like this, right? East Kentwood bigger than RHS. If East Kentwood has a higher mean than RHS in these samples, what would happen when I subtracted these? If I did East Kentwood minus RHS, what kind of number would I end up with? I'd end up with a positive number, and all positive numbers are bigger than 0. There's my boundary. If you want to look at it like an algebra equation, I subtracted RHS from both sides. And so that's how I got a 0 over here, and I see my inequality is a greater than. So now I can draw my picture. Now I know what my boundary lines are. Is this a lower bound or an upper bound? That's a lower boundary because we're going to shade it to the right for a greater than. So go ahead and draw your picture, and then I'll show you mine in just a moment. Draw your picture, put your mean on there, put your boundary and your shading on there, put your N with your mean and your standard deviation. should look kind of like this. 1.02 right down the middle, because that's our mean. 0 is to the left of that because it's smaller than 1.02, but then we said we're shading to the right because we have a greater than. Standard deviation of 0.282. So what we're going to pop into the calculator is this. I want the probability that when I subtract the sample means for East Kentwood and RHS, I end up with a number bigger than 0. I end up with a positive number. So we're going to do normal CDF, 0 for my lower bound. Upper bound is something stupid big. Mean of 1.02 and standard deviation of 0.282. Does anybody have an approximate value for this probability? Yes. 0.999. I even took it out one more because we get like 0.99985, so I rounded it to 4 places. Word of warning here. I love that you said 0.999. I would never round this up to 100%. If you round this up to a solid 1, you're saying there is a 100% probability. It is guaranteed that the sample from East Kentwood is going to have a higher average than the sample from RHS. I don't know that it's guaranteed. It's practically guaranteed, but there's a little bit of wiggle room. Unless what comes out on my calculator is exactly a 1, I'm never going to put down a 1 or a 100% for this. So even if it comes out to 0.999, I will leave it as 0.999. So far, so good? All right. So between before break and now post break, we've covered a lot. We've talked about sampling distributions for proportions. We've looked at sampling distributions for a difference of proportions. We have sampling distributions for means. And now we've looked at a sampling distribution for a difference in means. When we're talking proportions, we check for normality with what? Not means, but when we have proportions. When I have a p or a p hat, how do we check for normality? Looking for 2 words. The first word starts with an L. Large counts, yes. When we have proportions, p, p hat, when they give you percentages, we check for normality with large counts. N times p greater than or equal to 10, n times 1 minus p greater than or equal to 10. Number of successes is at least 10, number of failures is at least 10. If that's true for both populations, if I have 2 samples, 2 proportions, then that difference will also be approximately normal. When we're talking about means, it's a little bit different. I can't check for successes and failures when I'm just talking about an average score, or an average grade, or an average height, or an average anything. So instead of checking successes and failures, instead of looking at percentages and the mean, we need to look to see if the population is approximately normal. If it is, we're good. Or we can check for the central limit theorem, where my sample is at least 30 or more. That has to be true for both of my sampling distributions when I'm looking at a two-sample mean situation. The center, I subtract the means from the two samples, the two population means. Variability, don't forget to check your 10% condition first, and then you do the square root of sample 1's population standard deviation divided by the number in sample 1, plus sample 2's population standard deviation divided by the number in sample 2, square root of the whole thing. I would like for you guys now to spend about 5 minutes doing the check your understanding. It's very similar to what we just did on the front side, and then we'll compare your work with mine. Is it more expensive to live in California or Florida? Monthly cost of living expenses for California are approximately normal, with a mean for California of $10,800 and a standard deviation of $3,200. Monthly cost of living expenses for Florida are approximately normal, with a mean for Florida of $8,500 and a standard deviation for Florida of $2,700. Suppose we select an independent random sample of 16 residents of California and 9 residents of Florida and calculate the sample mean monthly living cost, X bar C and X bar F. What will the shape of the sampling distribution be? Approximately normal. Why? Because both population distributions are approximately normal. So the sampling distributions will be approximately normal for both. So the difference will be approximately normal. What is the mean for the standard deviation of the sampling distribution of X bar C minus X bar F? 2,300, absolutely correct. You're going to subtract the mean for California minus the mean for Florida, so 10,800 minus 8,500, we get 2,300. What do I have to do before I do standard deviation? Check 10%. Do you think that 16 is 10% or less of all the residents of California? Yeah, so we're good there. I do have to make sure to say all California residents, not just California residents. I want to make sure that we're talking about all of them because this has to be the population. This is one of those keywords that if it's missing on the AP exam, they'll say, you didn't talk about the whole population. That's why that word all is so important there. What else do I need to check? I need to check Florida also. What am I checking on Florida? What would I write down on my page to show that I checked this? 9 is less than or equal to 10% of all Florida residents. Is that a safe assumption for us to make? Yes. So then we calculate the standard deviation, and you get about what? I got something smaller. I got 1,204.16. If that's not what you got on the calculator, my guess is it's a difference between like what the calculator assumed you were inputting and what you meant to input. So if that's not what you got, I want you guys to try chunking it instead. Like put the first fraction in, get a number. Put the second fraction in, get a number, then add them together, and then square root that whole big number. Because sometimes when you try to put this in all as one big piece into the calculator, depending on the calculator, it's going to fuss about it a little bit. I'll give you guys a minute to see if you can find your error if that's not what you got before we go on to the next piece. So take about a minute. I'm going to move around. If you cannot get it to give you 1,204-ish, please let me know. Is there anybody that needs help figuring out how to get this number? Sometimes generous use of parentheses around things will help fix the problem as well. And it's I always like, if I'm using a calculator that I'm not 100% sure exactly how it's doing things, if it doesn't look on the screen exactly the way it looks on my page, I'm either using parentheses or I'm going to chunk it out. What I'm going to guess happened, because if you typed in the square root symbol and then you did the first fraction plus the second fraction, it probably only did the square root of the first fraction and not the second one. Is possibly what happened there. It all depends on exactly the way the calculator is programmed. Are we good on 1,204 and 16 cents? All right, then let's go on to part 3 then. You might need to recalculate. If you did not have this originally as your standard deviation, you might need to recalculate your probability here. Calculate the probability that the average monthly cost of living expense of the 16 randomly selected California residents is less than the average monthly living cost, average monthly cost of living expense of the 9 randomly selected Florida residents. What are they telling us there? Like, why did they give that information? What are they trying to help us find here? Boundaries. We're going to have a boundary where? At 0. We want average monthly cost in California to be less than Florida. Yep, very bottom paper over there. So our boundary line is going to be at, I feel like I asked this already, but if not, at 0. Which way are we going to shade it? To the left this time. I want California to be less than Florida, so I subtract x bar f from both sides. I have x bar c minus x bar f is less than 0. So far, so good? All right, so your picture should look like this. Yes?
I put 1.159 and 0.16 when I get
0.159? No, that'd be fine. That'd be totally fine. I went with 0.16 just because we were talking specifically about money here, so I rounded to the nearest penny. But there's absolutely nothing wrong with giving more decimal places. Would you expect this one to have a probability like what it did on the front side, that 0.999? Just looking at the picture, give me a reason for why you would not expect a 0.999. It's on the left, but last time wasn't 0 on the left, but we shaded to the left this time, and last time we shaded to the right. How much of the picture do we have colored? A smaller portion, definitely less than half, right? I kind of use that mean line as my cutoff because I don't always know exactly how many standard deviations out I am, but I do know that if it's on the left side and then I shaded left, it should be under 50%. If it's on the right side and I shaded right, it should be less than 50%. If I've colored the mean line and beyond, then I should expect a number that's bigger than 50%. What'd you guys get for your probability here? Yep, 0.028. 0.0281. Nicely done. Next semester, all of this comes back. But this is our first introduction to it. We're going to use all of these same pieces. So rather than load up new stuff and teach you this on top of it, we're going to use this now as a tool second semester. So that's why we're learning this by itself right now, because it's a lot. You guys get the formulas for standard deviation. You get the formula for mean. For both proportions and for means, 1 sample and 2 sample. If you look at your formula sheet, that you guys should still have a copy of somewhere, hopefully. The formulas that you're going to use for the test are these 2 boxes here. So back side of the front page, this had the formulas that we used on the last test. On the back side of that, it's these 2 boxes. The top is for proportions, so percentages or fractions. Anytime we have a p or a p hat, it's going to be up here. If it's for means, for averages, That's going to be in this little box down here. All right. So far, so good? All right. Homework is due Thursday. You guys can do everything on there. The 2 sample stuff is question number 4 on the homework. Questions 1, 2, and 3 are just 1 sample. Sometimes it's going to be an approximately normal population distribution, and sometimes you're going to have to use your central limit theorem, your CLT. Tomorrow, we will do free response practice. Thursday, we'll grade your homework. We'll do multiple choice practice. I will have gotten the test review to you before this. My goal is to get it to you guys tomorrow. I'm making a couple last minute tweaks to it, so assuming that all goes well and I get it printed, you'll have access to that tomorrow. And then test is on Monday. Questions over the test on Friday, or questions over the test review on Friday.